Right, before we begin, please remember that your score is going to be out of 15. So when you're done, you are going to put your score up here. You also, as an addition to writing a score for each part, you will make sure that you have corrected each part as well, if you needed to. All right, number one, the number of butterflies spotted in Emily's garden each afternoon is modeled by a differentiable and increasing function, h, for t being between 0 and 14, where t is measured in days. Selected values of h of t are given in the table above. Okay, for part A, it says to use the data in the table to find an approximation for h prime of 8 and using correct units, interpret the meaning of this value in the context of this problem. Okay, so first of all, finding h prime of 8, we know that h prime, if this is h, that will be a derivative. So we're looking for the derivative or the slope at 8. So I am going to pick the 2 points on either side of 8, which would be 7 and 9. So the slope for that would be the y values subtracting over the x values subtracting. That would give me 4 over 2, which would be 2. Okay, and then it did say to interpret it, we need to have 3 things in our interpretation. First of all, we need to have when. So at t equals 8 days. Okay, what is changing? H is changing, so the number of butterflies. And then I need to decide, is that number increasing or decreasing? Since h prime was positive, the number of butterflies is increasing. And then we will say at what rate. So at a rate of 2 butterflies per day. And if you are not sure on the units of that, again, we're just taking the y, which was the number of butterflies, divided by the x, which was the number of days. So you would get 1 point for the approximation. So if you found out 2, you would get 1 point. And then if you you didn't have to write it exactly like me, but you did need to include those 3 pieces. When did it happen? How fast did it happen? And what was changing? You need to include all that stuff. That would be worth 1 point. So this one was worth 2 points. So please give your score right there out of 2. All right, part B, explain why there must be at least one time between 0 and 14 such that h prime of t is equal to 1.5. Hopefully at this point in time, you're getting pretty used to them talking about an interval and a derivative, and we know somehow we are going to be referring to the mean value theorem. So I am going to test this to see if I can get a derivative of 1.5 or an actual slope of 1.5. So I'm going to try h of 14 minus h of 0 over 14 minus 0. So if I look up h of 14, that is 22, minus h of 0 is 1, over 14 minus 0. So 22 minus 1 is 21 over 14. If I put 7 into both of those, that does reduce to 3/2, which is 1.5. So please notice that I found that my average rate of change is 1.5. So now I'm going to refer to the mean value theorem. And I do need to make sure that it does say that it's differentiable. So it does say. So I'm going to say since h is differentiable, which implies that it is also continuous, then I can say then by the mean value theorem, and then I'm pretty much just going to restate what they put there. Then by the mean value theorem, there must be at least one time t 0 such that h prime of t equals 1.5. So please notice I pretty much just spit their words right back at them, but I did make sure I used the mean value theorem first. And we do want to show this work right here to make sure that that will work okay. I also tried this. When I first looked at the 14 and 0, I didn't think it was going to give me 1.5. So I actually tried another one. I tried at 7 and 5. We could have done that same thing for 7 and 5. And notice we would have gotten 7 minus 4 or 7 minus 5, which was 2. So notice I could have used that same thing. So as long as I show somewhere, I'm going to get a slope of 3/2 or 1.5. That works. Okay, so points on this one. This one was worth 3 points. Okay, we would have gotten 1 point for making sure that we said that h was differentiable as well as continuous. So that would have been 1 point. And then as long as we found an average rate of change equaling 1.5, we would have gotten another point. And then if you made a conclusion using the mean value theorem, you got your third point. Okay, part C, approximate the value of h of t, the integral of h of t from 0 to 14, using a left Riemann sum on the subintervals 0 to 5, 5 to 9, and 9 to 14. And then is this approximation greater than or less than the actual value? Give a reason for your answer. All right, so if we're going to do a left Riemann sum, my intervals are going to be 0 to 5, 5 to 9, and 9 to 14. And notice we're really not using those in-between numbers, the 3, the 7, and the 12. If I want a left Riemann sum, the distance between 0 and 5 is going to be 5. And then the left between 0 and 5 is 1. Okay, from 5 to 9, that distance is 4. The left on between the 5 and the 9 is happening at 5, which is 4. And then plus between 9 and 14, then distance is 5. And the left between the 9 and the 14 is the 9, and that y value is 11. So 5 plus 16 plus 55, that will give us 76. All right, and it didn't ask for units, so I'm not going to put units on this one. And they said, is this approximation greater than or less than the thing? So if we want to, first of all, it does say that it's an increasing function, so that's important. So if we have some sort of increasing function, and I do a left sum, so I'm going from the left, notice that I'm going to end up getting an under approximation. So the approximation is less than 0 to 14 of h. And then we're going to give two reasons. It's going to be because h is increasing and we are doing a left sum. So for those two reasons, because if you were doing a right sum, the approximation would be greater than. So we do want to mention both of those things. All right, so this problem was worth 3 points. Okay, if you did you actually used the Riemann sum formula, you're going to get a point. If you actually came up with the 76, you're going to get another point. And then if you were able to explain and having a nice reason, and it might not have been exactly the same as mine, but you want to have it something close to that, you'd get an extra point. So this one was out of 3 points. Okay, part D. The number of bees spotted in Emily's garden during the same 14-day period, she's got lots of stuff going on in her garden, is modeled by the function g of t, given, where t is measured in days. At time t equals 8, is the number of bees increasing at an increasing rate, increasing at a decreasing rate, or neither? Based on your answer, what can you conclude about the graph of g of t at t equals 8? So first of all, if I want to know whether something is increasing or decreasing, I'm going to be referring to g prime. And then if I want to know if it's increasing at an increasing rate or decreasing rate, I need to know something about g double prime. So we're going to find g prime of 8, and we're going to find g double prime of 8. So if we do this, let's see here. If I want to find, there's actually a couple ways that we could work this. I could, just to get g prime of 8, since I know g, I could at right this step use math 8. My only issue is going to be then to get my second derivative. I don't have a formula for the first derivative, which is going to make that a little bit more difficult. So we could just use that to verify our answer, I guess. So I'm going to start by actually finding g prime of t. Okay, the derivative of 7e to the 1/7 x minus 1 is going to be 7e to the 1/7 x minus 1 times the derivative of the 1/7 x minus 1, which will be 1/7. I was just using e to the u du. And then plus, this next part is really going to be, if I would think of this as a cosine u, and the derivative of cosine u is negative sine u du. So when I'm finding this, it's going to be negative sine u, which is 2x minus 16, times the du, which would be 2. So that is a formula for g prime of t. So if I'm wanting to find g prime, and actually I'm going to simplify that just a little bit so it looks a little better. So the 7 and the 1/7, they're going to cancel each other out. So this is just going to end up being e to the 1/7 x minus 1 minus 2 sine of 2x minus 16. All right, so then when I'm finding g prime of 8, if I plug 8 in, we'll get 1/7 8 minus 1 minus 2 sine 16 minus 16. This will end up giving me 1, and this will end up giving me 0. So when I figure that out, did I do that right? Where did I lose my 1/7? No, I did not. Oh, okay. So anyway, here I'm going to end up getting, this is just all going to be 0. I believe I'm just going to end up getting E, which is like 3.1 something. I'm just looking at it. I did that right because I wasn't looking at anything. Okay, yes, I do believe I'm I'm good with that, excuse me. So then from here, that is a positive answer. So we do know that the function is going to be increasing, and you could check using Math 8 to make sure I did it right. And then getting the second derivative, a couple things I could do again. I could, from here, just use Math 8 since I know G prime now, or I could go ahead and find G double prime using the same thing method of finding G prime. I'll use G double prime, so I'm going to end up getting 1/7 e to the 1/7 x minus 1 minus, this one will end up being 4 cosine 2x minus 16. And then if I plug 8 into there, I'm going to get 1/7 e to the 1/7 times 8 minus 1 minus 4 cosine 16 minus 16, which is 0. This is going to be 7 times 1/7, so I'm going to get 1/7 e minus, the cosine of 0 is 1, so this is going to be 4. So if you think of this, whether it's going to be a positive number or a negative number, 1/7 times e is like 2 point something. So if I have 2/7 minus 4, that is going to give me a negative number. And we found for G prime that it was a positive number. So if I want to know what is happening with the number of B's, so the number of B's is increasing at a decreasing rate, because we got a negative for the second derivative, at t equals 8, because G prime of 8 is greater than 0, and G double prime of 8 is less than 0. And then it also says, based on your answer, what can you conclude about the graph of G? Well, if we found out that the second derivative was less than 0, we would know G at t equals 8 is concave down. All right, so this would have been worth, oh my goodness, all that work, and we just got 2 points for it. That was a ripoff. Okay, so we get 1 point for saying this. So if we found all of that and found out, yes, it is increasing at a decreasing rate, and why, we got a point. And then if we were able to say that G of t, is concave down with a reason, then we'd get that second point. So that's how we get our points for this one. Okay, part E. The number of bees spotted in Emily's garden can also be modeled by the function b of x is equal to 50 square root of k plus 2x. Notice this time it's not b of t, it's just b of x. So things are changing a little bit, where x is the daily high temperature in degrees Fahrenheit and k is a positive constant. When the number of bees spotted is 100, the daily high temperature is increasing at a rate of 2 degrees Fahrenheit per day. According to this model, how quickly is the number of bees changing with respect to time when 100 bees are spotted? So there's a few things that are given to me. Couple things, let's see, the number of bees spotted is 100, so we know that B equals 100. We know that the daily high temperature, which is x, is increasing at a rate of 2, so we know dx dt is equal to 2. And then it's saying how quickly is the number of bees changing with respect to time. So it's asking us for dB dt, so all of those things. So where it's kind of like a related rates problem, there's just going to be a little catch in it. Okay, so I'm going to go ahead and take the derivative of this. If we're looking for dB dt, there's going to be a little trick to this. So when I go to find the derivative of b of x, it actually is going to be dB of t is going to be the derivative of b with respect to x times dx dt, because when we're taking the derivative of x, we also need to multiply by with respect to time. So that's the formula that I'm going to be using when I'm done. But the first thing that I'm going to do to find dB dx, that is simply just b prime. So I'm going to be finding the derivative of this function right here. And I don't have to worry about time right now. I'm just simply taking the derivative. So this would be another way of writing this. And then I'm going to write it one more way with just u to the 1/2. Our u is going to be k plus 2x. Our du, since k is a constant, is just going to be 2. All right, so when I go to take the derivative of this, I'm going to get 1/2 times 50, which will be 25, u to the negative 1/2 times du, which is 2. So that is going to give me 50 over the square root of u. So that will be 50 over the square root of k plus 2x. So I now have b prime, or another way of looking at it, I now have just found db dx, which was 50 over the square root of k plus 2x. All right, and then times dx dt, they already told me that dx dt was 2. So now from here, we're just going to be trying to figure this out. It said it was happening when b is equal to 100, so I need to do something with that 100. So I'm actually going to go into this formula right here for a little side trip. So I'm going to have 100 equals 50 square root of k plus 2x. I'm going to divide both sides by 50, so that's going to give me 25 equals the square root of k plus 2x. To get rid of the square root, I'm going to, I'm going to square both sides. Oh, 100 divided by 50 is not 25. Sorry, it's 2. I knew it was like something is going wrong here. Okay, 2 squared is 4 is equal to k plus 2x. I'm really not sure what I'm solving for here, but I'm guessing I'm going to solve for k. So I don't think if I solved for x, it's going to get me anywhere. So if I solve this for k will equal 4 minus 2x. So I did a side trip. I'm going to see if it helps me out at all, which you'll see in a minute. It definitely does. So I'm going to put that k up into this problem right here. So I'm going to have 50 over the square root of 4 minus 2x plus 2x times 2. Notice that was very nice because then the 2x is canceled out. So I end up getting 50 over the square root of 4, and the square root of 4 is 2 times 2. So my answer ends up being 50. And how quickly is the number of bees changing? So 50 bees per day. Alrighty, so let's see how we would get some points on this one. Again, this was a little bit tricky. You're going to get, let's see, it was worth 4 points if you use the chain rule. So if you somehow had the dx dt in there, somehow using that chain rule, you are going to get 1 point. If you were able to find out that db dt, this ended up equaling 25, you're going to get a point. And then if you were able to get the 50 bees per day, you would get your final point. So that would have been worth 4 points. So please make sure that you go back at the front, at the top, you put your score out of 15, and you should be good to go.